This section examines the inline injection pump. Some diesel engines use inline injection pumps to meter and raise the pressure of the fuel. The basic principle is for a plunger to act on a column of fuel to lift an injector needle off its seat. Inside the pump is a pumping element and a delivery valve for each cylinder of the engine. The element has a barrel and a plunger that fits inside it. Their accurate fit and highly polished finish ensures only minimal fuel leakage past them without needing positive seals. The barrel usually has two holes or ports, called the inlet port and the spill port. They connect the inside of the barrel with the gallery. The gallery contains filtered fuel from the low pressure system. At the top of the barrel is a delivery valve holder, and the pipe to carry fuel to each cylinder. The upper end of the plunger has a vertical groove extending from its top to an annular groove. The top edge of this annular groove is cut in a helix, also called the control edge. Some pumps have a helix cut on top of the plunger. A camshaft, cam follower and spring move the plunger in a reciprocating motion. When the plunger is below the ports, fuel from the gallery enters the barrel above the plunger. This ensures the barrel is full of fuel. As the camshaft rotates, the plunger is pushed past the ports. The highly polished surfaces cause a sealing effect, trapping the fuel above the plunger. Moving the plunger further raises the pressure of the fuel. This forces the fuel out past the delivery valve along the fuel line to the injector. Fuel flows to the injector until the control edge uncovers the spill port. The pressurized fuel above the plunger then moves down the vertical groove to the annular groove and into the spill port. The delivery valve stops fuel leaking from the pipe back into the element. It reduces pressure in the fuel line to ensure there is no dribbling by the injector. The delivery valve has a relief plunger and a conical face which is held against its matching seat by the delivery valve spring. The relief plunger on the valve is a close fit inside the bore of the delivery valve seat. When the fuel pressure rises, the delivery valve is lifted off its seat. When the plunger is clear of its bore, fuel flows to the injector. When injection ceases, the pressure below the delivery valve drops to gallery pressure. Fuel pressure above the delivery valve forces the valve towards its seat. The relief valve enters the seat bore, sealing the volumes above and below the delivery valve. Further movement of the delivery valve towards its seat increases the volume in the injector pipe and reduces the pressure in there. This drop in pressure causes the injector needle to snap shut, helping to prevent fuel dribble from the injector. The conical face of the delivery valve then contacts the seat, further sealing the plunger from the injector pipe. Rotating the plunger controls the length of the stroke for which the spill port is covered. This is called the effective stroke. It influences how much fuel is delivered to the injector. A short effective stroke means a small amount of fuel is injected. A longer effective stroke lets more fuel be delivered. To stop the engine, the vertical groove on the plunger is aligned with the spill port, which stops pressure in the barrel rising. The plunger is rotated by a control sleeve, a rack and a pinion. Moving the rack rotates the pinion, the control sleeve and then the plunger. The rack's movement is controlled by the governor.